Mantle Network is a modular Layer 2 blockchain built on Ethereum, designed to combine scalability, security, and decentralization through a layered architecture. Instead of functioning as a single monolithic chain where execution, consensus, and data availability are tightly coupled, Mantle separates these components into independent modules that communicate through standardized interfaces. This modular design allows for greater flexibility, lower transaction costs, and easier upgrades without compromising Ethereum compatibility. At its core, Mantle is an optimistic rollup that aggregates user transactions off-chain before submitting them to Ethereum for final settlement. This approach significantly reduces gas fees and increases throughput while maintaining the security guarantees of the Ethereum mainnet. Each batch of transactions is processed by a sequencer, verified through fraud proofs, and finalized on-chain after a challenge period. What distinguishes Mantle from other Layer 2 solutions is its use of external modular components, especially its integration with EigenDA, a decentralized data availability layer developed by EigenLayer. By outsourcing data storage and validation to EigenDA, Mantle achieves faster block confirmation and reduced costs for data posting. The Mantle design can be visualized as three coordinated layers: the execution layer, the consensus or settlement layer, and the data availability layer. The execution layer runs the Mantle virtual machine, an optimized environment fully compatible with the Ethereum virtual machine, EVM. This means that any Solidity smart contract or Ethereum-based decentralized application can deploy on Mantle without modification. The settlement layer connects directly to Ethereum, anchoring state roots and ensuring that all transactions ultimately inherit Ethereum's security guarantees. The data availability layer, provided by EigenDA, ensures that off-chain transaction data remain accessible and verifiable by anyone who wants to reconstruct the Mantle state. Together, these layers create a network that is both modular and trust-minimized. Mantle's architecture also includes its own token, Mount, which serves multiple roles. It functions as the network's native gas token, powers governance decisions through Mantle's decentralized autonomous organization, and provides collateral for validators participating in the rollup security model. The token originally evolved from BitDAO's BitToken, as the two projects merged into a unified ecosystem under the Mantle brand. Holders of BitTokens were able to migrate to Mount on a one-to-one basis in mid-2023, consolidating liquidity and governance into a single token economy. The governance system plays a central role in Mantle's long-term sustainability. Decisions about protocol upgrades, treasury allocations, and partnerships are made through community proposals submitted to the Mantle Governance Forum. This decentralized approach aligns with the project's goal of becoming a fully self-governing modular ecosystem, where stakeholders shape both the technical roadmap and strategic development. Treasury funds inherited from BitDAO are managed transparently and deployed to support developers, DeFi integrations, and ecosystem growth. From a developer perspective, Mantle emphasizes accessibility and performance. The network supports standard Ethereum tooling, including MetaMask, Hardhat, and Truffle, making migration straightforward for existing projects. Developers benefit from lower gas costs, high throughput, and fast transaction finality while retaining full Ethereum interoperability. The modular framework also enables continuous experimentation with new components, such as alternative data availability solutions or zero-knowledge proof integrations, without requiring a complete network redesign. Security remains anchored to Ethereum's consensus layer, but Mantle's modular design introduces additional resilience. By distributing responsibilities across specialized layers, the network can isolate and patch vulnerabilities more efficiently than a monolithic chain could. EigenDA's cryptographic attestation mechanisms ensure that all off-chain data remain publicly verifiable, reducing the risk of data withholding or manipulation. Economically, Mantle aims to balance scalability and sustainability. Transaction fees are structured to cover sequencer and validator costs while redistributing a portion of network revenue back to the DAO treasury. This circular funding model supports long-term ecosystem incentives and aligns user activity with community growth. In addition, Mantle's modular design allows for future optimization, such as integrating zero-knowledge rollup proofs, which could further reduce costs and improve trust guarantees. Since its mainnet launch in mid-2023, Mantle has positioned itself as one of the first production-grade modular Ethereum Layer 2 networks. The project's development roadmap includes broader integration with Layer 3 scaling frameworks, multi-rollup coordination, and expanded use of restaking through EigenDA. By decoupling the traditional blockchain stack and introducing modular components, Mantle provides a blueprint for the next generation of scalable Ethereum-compatible networks. As the broader crypto ecosystem moves toward modular and multi-chain architectures, Mantle represents a significant step in that evolution. Its combination of optimistic rollup execution, decentralized data availability, and DAO-governed treasury management demonstrates how modular blockchains can adapt quickly to new technologies while preserving decentralization. Whether viewed as an efficiency layer for Ethereum or as a model for future multi-chain design, Mantle Network highlights the growing importance of modularity in blockchain scaling. For more insights on Mantle, modular Layer 2 networks, and the evolution of Ethereum scalability, remember to like, subscribe, and keep learning, here at Crypto in Black and White.